afternoon, everybody. My name is Dominique Bachelet, and I am an associate professor in biological and ecological engineering at Oregon State University. I've been a climate change scientist since 1989. And in the last decade or so, I have focused my energy not only on creating content, but also designing a variety of communication tools to share climate change information. This year, it's my great pleasure to announce that the Corvallis Arts Center has generously chosen to host an art show this fall dedicated to climate change under the title, What Will Nature Do? The public media has been very effective at inflating the importance of climate deniers and at focusing on the worst negative aspect of the projected changes. The writing of these journalists has been found to cause denial, numbing, apathy, and more importantly, despair and hopelessness among the young. Today, we know that climate change is here, and we have seen the youth of the world rising and demanding action to limit the negative impacts on their generation. There are many ways to envision the future, and as a modeler, I've spent quite a bit of time simulating transitions towards a world adapted to warmer conditions. Given the inertia that has followed the thousands of publications, reports, and congressional hearings, I find it essential to diversify our approach to envision the future if we want to reach a broader audience. My optimistic view is that climate change was caused by us humans, thus we can do something about it. Many colleagues have talked about solutions and identified low-hanging fruits to get there. I'm hoping that through this series of lectures by scientists who are experts in their field, artists are inspired to give us their vision of what might happen when we get people engaged in working together in the spirit of responsibility and solidarity to fix the most egregious problem we've created. Today, it is my great pleasure to introduce our third science speakers. I have asked them to inspire artists by showing us how ecosystems do function to survive adversity through adaptation and evolution. So Dave Shaw got his PhD at the University of Washington in 1991 and worked at field stations for 14 years before coming to Oregon State University in 2005. Dave is a professor in the Department of Forest Engineering, Resources and Management, a forest health specialist with Forestry and Natural Resources Extension, and director of the Swiss Needlecast Cooperative, SNCC. The SNCC is a membership-based research cooperative focused on the foliage disease of Douglas fir. His research interests concentrate on applied forest biology and ecology, particularly regarding insects, pathogens, and mistletoe in forest. And a fun fact about Dave is that when you walk in the forest with Dave, you will focus on the insects and the disease and not on the trees. It's my great pleasure to pass the baton to Dave. Have at it.
All right. Well, thank you very much for that introduction. And it's a pleasure to participate in this and speak with artists and interested people that you know, we normally get kind of cloistered in the academic world and we're always talking to ourselves, although I do work in extension. So most of my time in terms of education is actually with outreach and extension. So I serve statewide through Oregon and collaborate with county extension agents. And we have a new fire program also in Oregon. So yeah, I guess the most fascinating thing about this when Dominique approached me about putting a talk together was to not focus on doom and gloom and to really talk about, you know, what will nature do and what are some of the positive things and some of the positive approaches or implications of some of the things that we see going on throughout the West in particular. So today's talk, I'll be focusing on bark beetles, and I guess I'll share my screen now. And all right. So what will nature do? Beetles, bark beetles have been, in particular, been implicated in a lot of the tree mortality that we see in the West. This photo on the left here is from the Klamath region, where in the 2007 to about 2012, we had a 350,000 acres of lodgepole pine, primarily lodgepole pine mortality. And it was so intense, people were calling it the red zone. And of course, you can imagine a lot of concern about that much bark beetle mortality. But I think there's some various ways to really conceptualize and think about all this mortality. And a lot of times we have to realize that not all tree mortality is bad. Dead trees create a lot of wildlife habitat and that kind of thing. And you could almost think of it as a fire. And it's, in a sense, it's a point in time through the succession and, ecology of forests in any particular region to be hit by bark beetles like this. Conifer-dominated forests in the West have really seen a lot of bark beetle activity, particularly in the last 20 years. The scale of this mortality is really seen as unprecedented, and it's thought to be really linked to drought in particular, and this concept of hotter drought, where the droughts, the general temperatures are much higher than previously, the average temperatures are much higher, and that increases the stress on the trees. So the drought is actually a worse drought when the temperatures are higher. This particular photo is from California and the lower slopes of the Western Sierra Nevada, where in 2012, 14 to about 2016, 17, they had a major drought, which was then followed by significant ponderosa pine mortality on the lower slopes. All these trees, all this mortality was associated with bark beetles. In this case, particularly the Western pine beetle, a common pine beetle that's important in ponderosa pine. But again, the scale of this really seems to be off the charts in terms of the perspective of the last 80 years, I would say, or 100 years. So, sorry about that slide there. So this is on the left. This is a image of the forested regions of the West. And you can see, when you think about the West, we often think about forests as defining the West, but when you look, the forests are really not that, super widespread in the West, and particularly concentrated along the coast, and then of course up in the north. The figure on the right is a paper that came out in 2012 and summarizing bark beetle activity in the first decade from 2000 to 2010. And you can basically see, if you look at the illustration on the right and the illustration on the left, pretty much everywhere there's forests in the West, particularly the interior West and not the coast, there's been bark beetle activity. And this is just one decade. If you include the decade from, the 2 decades from 2000 to 2020, there was increased activity. They don't even list several of the bark beetles that subsequently had outbreaks, the spruce beetle, particularly in Colorado. And so, in a sense, wherever there's forests, there's bark beetle activity, and these have been mapped. And this particular sort of idea that pretty much everywhere in the West, bark beetles have been important in the last 2 decades. And this does seem to be, a new thing. Now, over that 20-year period, there was one of the most epic outbreaks that we saw was in the mountain pine beetle. And the mountain pine beetle attacks pretty much all the pines, but it's really closely linked to lodgepole pine and large lodgepole pine mortality. This outbreak was, if you can consider both Canada and the USA, it was over 40 million acres that were mapped with mortality from lodgepole pine. And this particularly up in British Columbia, this area here in the central and southern British Columbia was just pummeled by bark beetles. Now, some context I think is really important here, because this region also went through some really epic changes over the last 120 years, 140 years. For example, if you remember the big burn, which happened in Montana and Idaho, was over a 1 million acre fire. I think over a certain period, about 10 million acres burned in western Montana and Idaho, eastern Washington. And then, you know, the same thing so around 120 years ago, we had two major things going on. One, the era of fire suppression started, and we had a lot of expansion into the rural areas with railroad logging and various kind of logging, and then also mining and mineral exploration. And a lot of times those folks would start fires. So there was sort of a reset in the entire region about 120 years ago, from 120 to 80 years ago. And that resulted in some fairly even structured, even aged lodgepole pine forests that had then developed subsequently over the next 100 years. And in addition, by suppressing fires, those regions then were the kind of reburns that we anticipate in a lot of these fires that occurred naturally, create a complex structure in the sense of changing the age classes. So essentially this, when you look at British Columbia there, that's a reasonably even aged lodgepole pines that occurred throughout the entire province that were between 140 and 80 years old. And those were, that age class is particularly susceptible to mountain pine beetles. So this interaction of mountain pine beetle and lodgepole pine in the West was somewhat created by the influence of humans on the structure of these forests due to fire suppression and the fires that were human caused 100 or so years ago. But this is a particularly important outbreak, though. I mean, it is unparalleled in history to have something this size. Now, this is what some of that country looks like during the outbreak. It's this red, you know, all these trees are freshly killed. So this is unimaginable numbers of beetles that were in these trees. And this is one of the classic landscapes from up there in British Columbia. However, so there's been some follow-up on this, and this group of entomologists and ecologists from U.S. Forest Service primarily did a big study of these in lodgepole pine forests of the Intermountain West and the outbreak that occurred between 2004 and 2019. And one of their take-home messages is that even though there was this epic mortality, lodgepole pine remains the dominant species in all of these sites that they looked at. And this is in, and despite increases in things like subalpine fir and Engelmann spruce. So what I mean is, so here is a figure from that paper, and this is for Colorado, Idaho, Montana, Utah, and Wyoming. They had long-term plots here, and so they had data from 2004 prior to the outbreak, and the red is lodgepole pine, the blue is Engelmann spruce, and the yellowish is subalpine fir. But you can see this is basically the mean number of trees that were per hectare. So if you divide it by 2 or so, it's acres. So they were averaging over 1,000 trees per hectare in these plots that they had. The beetles came through and had significant mortality, primarily of the dominant and codominant trees, the upper trees in the canopy level. But it didn't eradicate lodgepole pine. the stands remain dominated by lodgepole pine. So even through 2018, it may have cut the density of lodgepole pine by half, but lodgepole pine still dominates these sites. So when you look at that large sort of picture, the previous picture we looked at of mountain pine beetle, it seems extremely shocking, and it definitely has landscape impacts. But the fact of the matter is, lodgepole pine was not eradicated and is persisting on these sites. So that's an important take home, I think, regarding lodgepole pine. Just making sure my time is okay. So we also have a lot of activity of mountain pine beetle in Oregon. And this is a map from 2002 that shows mountain pine beetle from 2002 to 2011, when they really peaked in Oregon. The blue is the previous 8 years, and then the red is 2011. Down here in the southern part, you can see all along the Coast Range there. And in this southern area here, this is the Deschutes and Fremont-Wainema National Forest dominated here, is where a lot of the activity was there. So this is a really fascinating region of Oregon, but there's a lot of lodgepole pine here. The ponderosa pine was hit somewhat, but these outbreaks were primarily associated with lodgepole pine. Now, this gives us some sense of the acres of mountain pine beetle trends in Oregon. You can see, so this outbreak that started in 2004, and sort of it still persists. It hasn't really gone down much from 2012. So mountain pine beetle continues to kill trees, and with the current droughts in Eastern Oregon, we are seeing an uptick with Western pine beetle and ponderosa pine, and the mountain pine beetle in lodgepole. But look at this. In the 80s, we really got hammered, and we're talking, upwards of 2 million acres in Oregon from lodgepole pine mortality. And these forests have subsequently recovered. So this is a really interesting, this gave us an opportunity to do what we call a chrono sequence and go back in time. This is another picture from that zone from around 2008 in the Klamath country. It's what some of that landscape looks like. And you look at that and you just think, oh my gosh, that is completely roasted, and will lodgepole pine survive? But you do see elements of green through all of this. And so I just wanted to give a little context of this region. This is a map from a book by Jim Agee on fire ecology of the Northwest. And the areas indicated are lodgepole pine are climax forests, which means in the sense they aren't succeeded by other tree species like grand fir or Douglas fir or red fir, some of the other things. So this is ponderosa pine in the dark, and then this region of lodgepole pine climax is a really fascinating area, and that's where the mountain pine beetle really kicked in 2000, throughout the time, but particularly in 2008, and that outbreak really hit the climax lodgepole pine. Now, this is the region there. Here's Crater Lake for some reference, Roseburg. This area here is what we call the pumice plains. So Crater Lake blew up, and deep pumice was deposited here, and you get these rolling flats. And in those rolling flats, we get lodgepole pine as the climax species here. And these are uneven age stands of lodgepole pine. And then down here in the southern part, we get, these are more the uplands of the Fremont-Wainema National Forest. And here there's both lodgepole pine that is succeeded by true firs, but also lodgepole pine that is climax, so it persists on site. These are really low productivity, really harsh sites. But it's a really fascinating sort of natural history part of Oregon, where lodgepole pine, which is typically an early successional species, replaced by spruce and fir and other things throughout the West. In this particular region, it forms these climax stands because the region is the productivity in the site is so harsh, and it has this really unique pumice soils. This is a picture of that. So this is Bend up here in the north, and this is the Fremont Wainema, and these are the dates when the mountain pine beetle caused mortality of lodgepole pine. Here's the region that was hit in the 80s in the central portion. And then down here, this is that red zone. That's about 320,000 acres down here in the Klamath and the Fremont Wainema. And then it would also was a lot of activity up in the north end. So we use this chrono sequence to sort of look at, now we were interested in fuels and fire, but what I want to point out here is the fate of lodgepole pine. This is another picture of what we call the gray stage. So the leaves have all fallen off these trees. And this is some of the extensive mortality that occurred down there in the Fremont Wainema forest. So the effect of mountain pine beetle on these forests is really a time, sense, and outbreak type of phenomena, where you get an outbreak that may occur over 4 to 6, 8 years and causes a lot of mortality. And then that sort of resets the forest and you get a time, sense, mortality event pattern that then occurs when the stand recovers over the next several decades. And that influences the fuels complex, so that influences how it might burn. And it also influences the ecology of the stand and what's growing there. So these are some pictures. This is about 2 years after the outbreak really occurred. You can still see red dead trees with lots of red foliage, but there are still green trees in these photographs. Here's the outbreak about 4 years later, when most of the leaves are falling off the trees. They're still hanging on some of the trees, but you can see extensive mortality here. You notice that the forest floor is really depauperate. It doesn't have a lot of vegetation. This is a really harsh site. These are the pumice plains where the soils are very nutrient poor, a lot of frost heaving and that kind of thing. And we don't get a lot of understory vegetation. But you can see there's still some lodgepole that are surviving here. Now, after about 19 years, most of the snags are coming down and you're starting to get regen. And you can see in some of these photos that the lodgepole is coming back. This is 19 years after an outbreak in sort of that stand. And there's still a few snags, but there's still larger trees that survive, and there's still a lot of smaller trees that survived, and then new trees coming in. And then 27 years, we were able to do this chrono sequence for about 30 years, 32 years. But this is what the stands look like. In some areas, lots of coarse woody debris, lots of large fuels, and of course this has an influence on fire patterns, but look at the regeneration that can occur in these kinds of areas. And a lot of these older trees are dead, but the regeneration is still coming back. So if you sort of think about this, we had these major mountain pine beetle outbreaks, but lodgepole pine persisted and it maintains. And so this figure on the right here is time since the beetle outbreak, and the green is the proportion of green live trees that were lodgepole pine, and then the red was recently dead trees with a red crown, and then the brown is dead 1 year older with brown leaves. But you can see you kind of have a lag of these dead red trees and dead brown trees, and then the foliage falls off of those, and those come down. They're either snags. The snags usually fall within about 15 years, to 15 to 20 years max. And then the stand goes back to lodgepole pine. So we're not losing our lodgepole pine in Oregon due to mountain pine beetle. Now on the west side, there's several beetles working on some of our trees, Douglas fir in particular, and the Douglas fir beetle here. These are the Douglas fir beetle in a dying Douglas fir. There's also these flat-headed fir borers. This is strongly linked with drought, but not all the Douglas fir beetles are dying. So this is some of the kind of mortality patterns we're seeing in the Willamette Valley, on the margins of the Willamette Valley now. But this was a group kill, but you still see green trees around it. We get these patches of dead trees. This is grand fir here on the left and Douglas fir here. And the grand fir has been hit by a fern grave or bark beetle. The Douglas fir has been affected by either the Douglas fir beetle or the flat-headed fir borer. But here again, this question of fire suppression and the role fire suppression has played is really important. And Douglas fir has really increased in abundance since fire suppression. The Native Americans, indigenous people used to burn routinely in the Willamette Valley for many reasons. And the oak-dominated forests of the region were the structure and composition of those forests were a result of frequent fire return intervals of less than 20 years for most of the sites in the valley margins. And so Douglas fir, then with fire suppression, Douglas fir and grand fir both expanded their numbers. So the density and abundance of Douglas fir is much greater in these areas now along the margins of the grand fir. And if you know much about this or heard much, many of the people doing restoration projects in the oak-dominated woodlands of the Willamette Valley focus on reducing the amount of conifer in those stands and allowing the oak to dominate more. In addition, the oak has reproduced in some areas much more. And so we used to have larger, the average diameter of the oak that grew in the valley was much larger than it is today. And we have we have a lot of smaller oak because of fire suppression. So is what's happening now in the Willamette Valley with this pretty significant Douglas fir mortality we're seeing, and we know it's related to drought, but is that actually just sort of nature's way of restoring back to these oak-dominated woodlands that used to occur here? That's just something we need to think about. I mean, I know as a landowner, I was, 5 acres, but a lot of my Douglas fir died, and it's a real problem to manage because I don't want them hitting my house and that kind of thing. But on the flip side, it's probably, a consequence of fire suppression then interacting with drought is why we're having so much Douglas fir and grand fir mortality around the Willamette Valley. So perhaps in a sense, it could be seen as a good thing from the perspective of Oregon white oak. Okay, so I have a colleague, Patricia Maloney. She's works for University of California down at the Tahoe Environmental Research Center. And she really has, she's a really amazing person. And we talk a lot about assisted migration and various other things, but she really has some strong feelings about climate change. And what she thinks is what is lacking is conservative optimism, that we really need to think more in the sense of, not just optimistic, just for the heck of being optimistic, but, careful, thoughtful optimism, and that how things might really be, how we can, I know we may be in the early stages of climate change and things may get worse and worse, but at this point in time, we still have some optimism left, I think. And so what she's getting at is there's these really, when we think about the ecological and evolutionary consequences of environmental change, what's some of the things that are happening in forests. And again, this is a slide from Patricia that she shared with me. So we talk about shifts in species composition and structure. We talk about genetic shifts within existing species because large mortality events affect the genetics of the population. And so one of the emerging themes that we're seeing now is climate change exerting selective pressure for drought resilience in forest trees? By killing the trees that are less drought resilient and leaving behind what we assume are drought resilient trees, is climate change then actually creating more resilient forest trees because they'll be more resilient to drought? This is another paper from a European group with a very provocative title: Increased mortality can promote evolutionary adaptation of forest trees to climate change. Now, this is a really interesting idea, and Patricia has really taken this idea also, but these folks studied European trees, Scots pine and silver birch, and they investigated how the length of the growing season would be positively or negatively affecting these trees. What they found was that the growing season was increasing faster than the trees were evolving to adapt. However, when you had a mortality event associated with this droughts or something, you know, associated with the growing season, what you actually did was you promoted adaptation of the remaining population of trees by killing the maladapted trees. So you're actually increasing resilience of the forest by causing a large, of a particular tree species, by creating large scale mortality. So this is a fascinating idea. You know, I think it, you know, depending on what happens with and how much the climate change, this is a really interesting idea. And Patricia has really taken this another step. So in the Tahoe area, this is Lake Tahoe, this is the basin, and they had a major mortality event from 2012 to 2016, and including 18 and 19. But they had a major 5-year drought event and they had a lot of mortality. So this photo on the right shows this is all sugar pine that's dying. And sugar pine is a real classic tree that everybody loves. And they're really concerned about losing it from this system. So in this Lodgepole Basin, you know, from 2015 to 2016, they had, you know, 72,000 trees. So a major, major effect in this Lake Tahoe region. So, however, what Patricia really feels like is those survivor trees are the key to the future. So she feels like this is the key to withstanding drought and climate change. So rather than go get, you know, do some assisted migration type of thing where you would go to the south and get seed sources there and bring them to the north, she doesn't really believe in that. And she thinks that we need to focus on the survivors and get seeds there. So she feels like the major mortality may improve resilience in the remaining populations because they had the genetics to survive. So she took that to the promised land. She went out, collected seed. She's rearing that seed. Here on the left, this is one of her greenhouse settings, or out settings. And then they're taking these seedlings out and they're reforesting with the seedlings from the survivor trees. And so she really feels like this is a possible, you know, if you're into restoration and reforestation for recovery, that this is a potential solution to drought-mediated and bark beetle-mediated mortality in some of these forest systems. So here again, she's saying, despite these high levels of sugar pine mortality, there was numerous surviving trees. She collected seed from those trees, and then she's repopulating. She wants to improve the population numbers, sort of reforest with some sugar pine, and then she's going to be planting that with local and diverse seed sources. And hopefully those trees will be more resilient to change. So I think that's my conclusions then on the, when I look to the positive side. And again, this is the red zone down in the Fremont-Wainema National Forest. And it looks pretty depressing when you look at a picture like this. But two things that so far, from what we're understanding, bark beetle caused mortality is not eradicating species. So it's obviously reducing the numbers. It's probably changing forest structure and composition, but it is not killing off the tree species so far. And in addition to that, major mortality events like this could be associated. Now, this is pretty hypothetical, I will admit, but this is something that's gaining some traction, that these could be associated with increased resilience of the mating population of trees, because these are the survivors. So with that, I just wanted to leave you with one thing. This could be our future in a sense. And as you may have heard from some songs back in the day, the future's uncertain and the end is always near for a tree in particular. But there is this idea that if you keep your eyes on the road and your hands upon the wheel, that we can maybe steer this into, some positive outcomes. And of course, that was the Doors. All right, so hopefully that was of interest. Like I said, I talk a lot about how many acres are killed by bark beetles, but I think we need to realize that those bark beetle, the bark beetles in our case, all these bark beetles are native, and we are seeing an uptick in activity, but there are survivors and they are revegetating and repopulating these stands. All right.
Thank you so much. That was great.
Great, yeah. So I hope that left you less depressed than you might have been about tree mortality and bark beetles.
Yes, I hope so. So I have a few questions for you. I'm going to start by one of my questions, which is, how important do you feel it is for lay people to know about your research and know your findings?
Well, that's, I feel, I'm sheepish about that because, of course, I think it's important that people, understand our research, and I do applied research, on Oregon forests in particular. And so I think it's important, but I'm a little sheepish about saying it's the best thing since buttered bread, or that everybody should read my research papers. So, I feel like, I think particularly interpreting it in ways that are understandable and that are relevant to people, I think is important. So I suppose I would say, yes, it's important. But I'm, like I said, I'm a little sheepish about saying I'm, saving the earth or anything like that.
And how do you think artists can help you communicate those results, since you've talked to artists?
That's a real novel question for me. And it's kind of exciting to think about that, artists would see this and then interpret it through their own eyes, and then create art that would, captivate, like particularly, the role of survivors in, the future forest. The forest composition may shift, but the survivors may, continue to influence, and the species continue to influence the forest ecology. And the, so I imagine some artwork with survivors and, forest stands and that kind of thing. But yeah, it's a really interesting idea, I think.
Yeah, we'll see what comes out of it. That would be cool. So a few questions from the audience. What does climax mean in this context?
Oh, interesting. So yeah, we often think of weather as, what's happening in the last year or so, and climate is the long-term trends. And
Climax.
so,
Climax, it's my accent.
oh,
Climax.
sorry about that. Climax. Oh,
Yeah.
many apologies for not defining that. So
Yeah.
oftentimes in forest ecology, we think about, when a site is disturbed by fire, for example, that you get what we get these patterns of succession. So there's early colonists that would come into a site, and then those are replaced by, like, those would be sun-loving trees, for example. So like in the Douglas fir forest, the fire comes, the Douglas fir grows. The Douglas fir is what we consider an early successional species, and then it's eventually replaced by shade-tolerant species that can reproduce in the understory, and those would be, hemlock and cedar, for example. And then it reaches this point where the cedar and the hemlock are are reproducing within the site. The Douglas fir completely dies out, and then we consider the cedar and the hemlock to be the climax species, because they're the ones that are going to self-perpetuate on the site in the absence of some kind of disturbance. Now, I will say the term climax has really taken a hit in the last couple of decades because of everybody's understanding of climate and climate change over millennia. And so it's kind of fallen out of favor in terms of a concept, but we still use it a bit in forest ecology. So climax is the tree that self-perpetuates on a site indefinitely in the absence of disturbance. Whereas, so like in the Northern Rockies, lodgepole pine comes in after a fire, but eventually it's replaced by spruce and fir. And if fire doesn't occur for 2 or 3 or 500 years, the site will eventually become a spruce fir forest rather than a lodgepole pine forest. And the spruce and the fir are considered the climax species in that case. Did that answer the question? I hope.
I think so. Debbie and John, if it didn't, you can speak up.
No, that was very helpful. And I think I just interpreted the last part of your explanation incorrectly when I asked, does lodgepole pine exceed the climaxiness of cedar and spruce? And I think you just said no, cedar and spruce, or spruce and fir,
right, but
will attain dominance.
Right, and then the lodgepole pine's a sun-loving species, especially in the seedling stage. And so if it gets shaded, if the forest floor is shaded, it just doesn't reproduce well. So it likes a mineral soil after fire. However, that's the interesting thing about the Oregon climax lodgepole pine stands. No other tree species apparently can grow there for various reasons, even ponderosa pine. So lodgepole pine it's a single species self-perpetuating site where the lodgepole is both the early successional and the late and the climax species. So it's a really fascinating forest there in the Pumice Plains.
And that's defined primarily by the soil, the nature of the soil.
Right, and you get this cold air drainage from the east slope of the Cascades, and you have this flat rolling pumicey plain. Right. And that cold air drainage then influences frost heaving. And apparently the seedlings of most conifer species can't tolerate the frost heaving, but lodgepole pine can. And so it's a soils, it's related to the soils and the this cold air drainage phenomena where the cold air comes out and then fills these low areas that, in this more flat rolling pumice plain area.
Got it. Thanks for helping me understand that.
Yeah, so that's south. If you're driving on 97 between Klamath Falls and Bend, you drive through extensive part of that pumice plain, and that's where lodgepole pine dominates everywhere.
Cool, thanks.
So Hester has the $1 million question. So large mortality is desirable?
Oh, well, I I'd be a little careful with that one. I I would say that if it'd be difficult to apply values to this, because values are really drive a lot of our thinking. But I guess what I would say is it's not all bad as opposed to being desirable. It's a little nuance there, but
Yeah.
it's not all bad because we feel like there are survivors of these events, and those survivors are probably the future for that species. That's the idea, I guess.
Mhm. So John went into economics and asks if increased mortality promotes evolutionary adaptation of forest trees to climate change, what might the impact be on the timber industry? Do drought-tolerant trees have higher or lower market value, at least today?
That's interesting. Well, what the industry, particularly the intensive management industry, they're operating on a really short rotation. So it's been suggested that industry, with a 45 or 50-year rotation, even or maybe even shorter, 35 years, could is actually a climate change adaptation because they can shift their species. So what we're seeing there is some emphasis on, because most of the industry is planting seedlings that are what we call genetically improved. So they've been through tree improvement genetics trials so that the tree grows straight and has these attributes: fast growth, straight growth, so that the log is, in good form and all of that kind of thing. What we're seeing is that they're starting to move some of the tree breeding programs to try to breed for drought tolerance as one of the various kinds of things that, so what they're trying to do is using these, and these are traditional genetics. These are not GMOs in the Northwest anyway. They're trying to breed both for fast growth, good form, and tolerance to various, depending on where they are. Tolerance to drought is one of the newer things that they're trying to incorporate into their tree breeding programs. So most of the industry relies on seedlings from genetically improved stock. So that would be more of a manipulation kind of thing that they're going. Now those seeds, they also use seed zones, and they collect seed from a zone with similar climatic characteristics as the zone that they're in. And there's a lot of controversy now about whether you should be collecting from another seed zone from a drier area, and that's pretty dynamic. We haven't seen a big move to that in industry, though. Industry is still using their seed zones, and they're depending on, and we're into, third generation sort of tree improvement trials. So they've been at this for a while, and particularly since the 50s and 60s. And these are 12 to 20 year kind of programs that then they plant seed orchards, and then they get their seed from the seed orchard. So I'm getting a little long-winded there, but it's more of an or a human sort of manipulated system in that sense. And so when they get more drought tolerant trees, the idea is they would still have these other attributes that they desire, like fast growth. In nature, I think it is quite possible that some of these drought tolerant trees would grow slower. But I think there's still a lot of research into that going on right now, trying to understand what the attributes of the survivors are. So for example, on the college forest, the Oregon State University College Forest here, there's some grad students working on that exact phenomena. They're trying to look at the trees that died and the trees that lived, and compare the way they were growing beforehand to determine whether the fast growers all died or whether the slow growers survived. And there's some interesting, and I think Patricia's also working on that in the sugar pine of the Tahoe region. So that's a big question that's actively being researched right now.
You got quite a few more questions. So are there insects that are not native? And if so, are they a greater threat or influence?
Oh yeah. So in Oregon, my current, I hate it, insect is, and I don't hate very many insects, is the balsam woolly adelgid. The balsam woolly adelgid is a non-native invasive aphid-like insect. And it's currently hammering subalpine fir at high elevations. And we're seeing a significant decline in subalpine fir associated with this balsam woolly adelgid. Previously, in the 1950s, when it was introduced into Oregon, it really hammered grand fir. And a lot of people thought grand fir was going to be lost from the valley, but grand fir seems to have responded, and now we kind of have some chronic infections from the balsam woolly adelgid in grand fir, but it seems to really have moved up in elevation, and right now it's really severely affecting grand fir. Another common non-native that we have in our forests and is the spruce aphid. And we see that kicking up in our Sitka spruce forests every once in a while, but it doesn't seem to be hammering it every year. We'll go like 10 years and then it'll flare up and then it'll go away. And so that doesn't seem to be hitting Sitka spruce quite and affecting it quite as badly as this balsam woolly adelgid. On the flip side, we have some diseases like sudden oak death, which we're currently corralling down in Curry County, and that is really having a significant impact on tan oak in particular. And it's basically a killer of tan oak, and that is definitely influencing the populations. And we haven't been able to find any resistance in tan oak that we've been hunting for. Another one is white pine blister rust, which was introduced to British Columbia in 1910 and spread throughout the Northern Rockies and has really influenced Western white pine in particular, and sugar pine and white bark pine. But we find that in that particular case, we do find genetic resistance. And that is the source of a major tree breeding program at the Dorena Center down in Cottage Grove, where they work on finding resistant genes, and then they breed those trees, and then they create seedlings. And they actually work within seed zones also. Same thing with Port Orford cedar root disease, which is another non-native disease that has affected Port Orford cedar in its native range. And the Dorena Center has developed genetically resistant stock, not immune, but resistant stock. And now anybody planting Port Orford cedar uses this genetically resistant stock. So there is some good news from that, but the insect, this balsam woolly adelgid, there's nothing, we've had it, for 70 years, and we don't have any controls. We don't have any, we've never been able to solve the problem, and it's basically really hammering us up in the subalpine fir. That was kind of long-winded answer. Sorry.
You said, that's okay. What caused the wide-scale mortality of lodgepole in Oregon in the 1980s? Was it drought?
So typically, what most bark beetle folks are hypothesizing currently is that in most cases, these bark beetle outbreaks are preceded by drought or drier than normal events that then allow the beetles to overcome resistance of the trees and then build their populations up. So we typically associate them with some kind of drier period. I haven't seen analysis of the 80s outbreak to the extent to know whether that's been definitely linked to the 80s outbreak. So I'm not 100% sure about that.
Yeah.
The other major part of that is forest structure and age class of the lodgepole pine stands. So density of the stands and the age of the trees is also really key. So the entomologists that I work with over on the east side, they often say that, you know, when a even age stand of lodgepole pine reaches a certain size class and the phloem is thick enough for the beetles to breed in, the inner bark, excuse me, is thick enough for the beetles to breed in, that then they become susceptible to beetles. So it's sort of a combination of the stand has to have trees of a susceptible size and that would dominate the stand. And then you would also have to have this often preceded by a drier than normal period.
Yeah, so wouldn't the subsequent regen be more drought resilient then?
Excuse me,
The regeneration, what regrows after a drought caused mortality, the regen should be more adapted to a drought. If we continue that line of
theoretically,
thought.
that's true, that these trees, you know, the drought resistance in these trees is continually evolving. And but lodgepole is pretty resistant to drought anyway. It can tolerate some pretty difficult conditions. But yeah, that would be theoretically the seedlings would be tolerant to drought. Although in most cases, lodgepole pine has what we call serotinous cones that require heat to open, such as fire. So the cones remain really closed and they're resin impregnated. And then when the fire burns through, it releases the seeds. So a lot of the trees that were killed by lodgepole may still be hanging on to seed that was, you know, from a tree that was killed by either drought or beetles, and then the fire burned through and were released. So that would be a way that they might not increase. You know, the population might not be as, you know, moved as some of the other tree species. The interesting thing is the lodgepole pine that grows in the pumice plain does not have serotinous cones. So in that case, we would assume that that's another one of the weird things about that population of lodgepole, is it doesn't have these serotinous cones, which are very common through the Northern Rockies.
So had fire policies been different, would the composition and diversity of these groves be different? How was our meddling with the natural process contributed to the conditions the beetles thrive in?
So probably the main thing is the fact that we had these even structured stands all regenerate in a similar period of time from, you know, the late 1800s into the early 1900s. And now they're all 120 to 140 years and they're all even, and it's across large landscapes. If we would have been allowing fires to burn, many of those areas may have had fires. So it would have, rather than having one age class across, you know, the entire portion of middle British Columbia, they would have had multiple different age classes. So the entire area wouldn't have been as susceptible because the age class differentiation, if that makes sense.
Yeah. What caused the mortality event leading to the huge area of even-aged lodgepole pine in BC?
So we think it's a combination of factors. One is the amount of lodgepole pine that was in a susceptible size class, age class. And then there was some drought activity in the early 2000s. And then once the population of beetles reached this sort of epic level, it just rolled through the whole region. I mean, there was so many beetles. The beetle did not occur on the east side of the Rocky Mountains prior to this outbreak. And there's some theories that there was so many beetles that atmospheric, when they were during their flight period, which is in the midsummer, some of these storms or whatever that came in from the coast lifted many of these beetles like up and took them over the mountains and deposited them on the east side of the Rocky Mountains there in British Columbia and Alberta. And the beetle has since then started spreading east through the lodgepole pine and through this sort of area where lodgepole pine meets jack pine. And jack pine and the beetles have moved into the jack pine. Yeah. And so that was kind of this epic evolutionary event in a sense. Is the population was so huge, it got, you know, this is theoretical, that it was lifted over the mountains and then deposited on the east side. And now we have beetles in this, what they call novel habitat, where they never occurred before. And in addition, the beetles are moving north, where due to global warming, because they have to be, the beetle is killed at winter temperatures. I think it's below, I believe it's the -20 to -40 degree isopleth up in the northern part of British Columbia. And that isopleth, that sort of area where it gets that cold is moving north. And so some of those forests are warming, and much of that northern region of British Columbia is being hit by beetles where beetles never occurred before. And so that's some of the problem in British Columbia and Alberta now, is the beetles have entered forests that have never been exposed. And there's been a lot of research that's compared the susceptibility of trees in areas where the beetles were common to areas where the beetles were absent. And the trees where the beetles were absent, of course, have less resistance to the beetle.
Yeah, when I learned about the BC outbreak, I learned that the -40.
-40.
It had moved north, and so that instead of having one generation, the beetles could have 2 per year. Thus, the increase in the population size. But
well, actually, it was, I think, a 2-year generation went down to a 1-year generation, and so far there's no evidence they're having multiple generations in a single year. But it was the 2 to 3 years that they might have taken. And the same thing happened in whitebark pine at higher elevations, where it would typically take 2 to 3 years for the beetle to develop. All of a sudden they were developing in 1 year, and that synchronizes the population. And they're able to the higher the population, the more they're able to overcome resistance of the trees.
So what happened 140 years ago in BC so that all the structure, and it was even aged up there? What caused that?
It was the miners. The miners used to just burn the hillside so they could see the rocks and such. And so, that was the wilderness or whatever. They just like lit fires and let them go. Yeah. It was kind of incredible.
Yeah.
What that landscape must have been like.
Yeah. So related to that, in known human history on the West Coast, have forests always been conifer dominated, or is that a new thing?
My understanding, for the last 11,000 years or so, since glaciation and such, it's been conifer dominated, although hardwoods, of course, have played a role. But I think, if we're just talking the last 10,000 years, I think it's pretty consistent conifer dominated. Is that your understanding, Dominique?
I think so. Yeah.
That's my understanding, is that, it was colder, at a time, and then there was a warming, and then it cooled off. And my understanding is it's been a shifting of conifers. Lodgepole used to dominate more on the west side, and particularly in the Puget Trough and that kind of area. But now it's pretty much, on the east side, except for shore pine, of course.
Right. And the next question was, is there something about conifer dominated forests which make them more vulnerable to beetle-caused mortality?
Yeah, in general, we think now beetles are not limited to conifers, but for some reason, it does appear to be sort of a conifer phenomena to get these kinds of outbreaks. But we also think there's this interaction with fire, particularly in the West. But yeah, you know, there are bark beetles of hardwoods. They tend to be more, you know, up in the crowns, causing partial dieback and that kind of thing. But for some reason, this relationship between conifers and bark beetles is really tight. And bark beetles, it's not every bark beetle. There's hundreds of species of bark beetles, but only a handful of them really have the ability to overcome the resistance of these trees and start killing, you know, large numbers of trees. And mountain pine beetle is sort of the most famous of all for that.
As trees adapt and become survivors, are genetic changes verifiable at some point, or is it mostly through observations of resilience?
Well, you know, to be honest, we're sort of in our early, this is all somewhat hypothetical. We're assuming some of this stuff, and we haven't, you know, the research is only now really expanding in this area. And so right now it's more of a theory that is beginning to be, you know, depending on the system, it seems to be working or not. And so I think it's something that is a novel idea, and a lot of us really think it might be worth pursuing. You know, particularly folks like Patricia Maloney and others. But, you know, it's really hard to say because there's so many other factors involved. You know, there's the other biota, you know, defoliating insects, invasive insects now that are moving into some of our systems, you know, so it's probably a little more complicated than I'm making it out to be, or is a lot more complicated than what I'm making it out to be. But it's a novel idea that we think, you know, has some validity. I don't know. Not sure I answered the question directly.
I think you did.
Okay.
Yeah. So I don't see any other questions from the audience, but I have one more. For the people who are listening to your talk, what's the one thing you want them to take away from for the things you said today?
Well, I would quote Patricia Maloney and say that we should really have conservative optimism. That I think, you know, we look at our mountains. I mean, there's threats abound, invasives, climate change, you know, human management, et cetera, but, you know, nature has a way of maintaining, and at least, you know, in the near term of climate change, I think, you know, I think we can really look to nature to sort of maintain things. I'm not a big proponent of what people call assisted migration. I'm afraid that that's not well understood and that we might trip ourselves up that way. But at any rate, I would hope everybody would have a little bit of optimism or conservative optimism about what is actually happening and how we might work to do restoration and reforestation associated with these big disturbance events.
Thank you very much, Dave. I really appreciate this. You did a great job with the talk, all the questions.
Okay.
And
well, thank you all very much for your patience, and hope you enjoyed this talk. And yeah, and so I do work with Extension. So if you ever want to get a hold of me, Dominique knows how to get a hold of me. But if you have any questions or anything, feel free to follow up.
Yeah.
All right.
And the talk is going to be recorded, has been recorded, and will be posted both on Facebook and on the Art Center website. And I want to thank our audience for being here today at this hour. And I also want to tell you, see you Monday when Derek Arndt is going to talk about climate. He's the Chief Climate Monitoring Scientist at NOAA, and he's going to talk to us about extreme weather events and how it's linked to climate change. So thanks again. Thank you, Dave, and thank you, our audience. And looking forward to seeing you again Monday.
Right. Thank you very much.
Thank you all.
Bye, Dave.
Bye.
Thank you.
Bye.